So hello everyone, I'll start my presentation. So I'm Cedric Lescop, I'm working for Schneider Electric. Schneider Electric is a big industrial company, so we have a different line of business. This means that we are producing lots of different products, so I won't talk about all of them. I'm working on the drives lab, so it means we drive motors to build other products like leverage or pumps control or stuff like that. And back in the days there was no need about communications, but today there is a lot of communication needs about field buses like can open Ethernet IP, backnet IP, device net and stuff like that. So we added to our product some option board, so we call that communication board to implement the field buses. And going there is to say that I'm a firmware architect on this communication board. I'm also working on projects that we call innovation project. So we are looking at different OSs, RTOS. So I'm really interested about Zephyr, so that's why I'm here today. And I will introduce you with a new feature in Zephyr, which is called LLEXT. So today I will introduce, I will tell you a little story about me and about my project. And it all started with an industrial need, a need about flexibility, because as for today, I think like maybe almost all firmware, not all, but most of the firmware are monolithic. That means we have to flash the whole firmware, and when you want to update it, you have to reflash everything. And our new need was to be able to amend a firmware without reflashing everything. So what's what we call flexibility. So why do you want that? Because as an industrial, the time to market is very important. So doing that it will mean that you don't need to do a verification about the whole firmware, to redo the whole validation, and maybe not the certification. So that's what we want to try to do, like having the base firmware on one side. That we do the verification once only, and then have the application on the other side, and redo only the verification if there is a problem on it. And that's it. So pretty much it. So just to give you a quick view about the image, what we want to do is that we have the product in the middle. So here is a soft starter, an ATS 490. Which used to have a monolithic firmware. So now we want to replace it with Zephyr OS. Today there is no, it's not yet done, but it's kind of my dream. On top of that, we can see that there is a proprietary infrastructure and the motor control. And what we want to do is like to add an application on top of it, maybe two applications. And by application, I mean anything. It's not only something that we can find about Zephyr sample test. It could be like something under modules. So as a communication architect, I'm looking at adding a new communication stack to the product without refreshing it. So what we have done, so as all companies, we have done the state of the art. So we were looking at what was already existing on the market. So the main idea was first, as industrial, to do it ourselves. So to do it the proprietary way. So that is really great in the first place because you can do it yourself. So you can implement everything as you want. But the counterpart is the backdraw is like as any proprietary code, you have to when you want to modify it, you have to reread it. If you hire someone new, he has to ramp up on it, and you have to understand it in the proprietary way. Just a quick story about that. Last week we had an engineer who retired, so it was working in Schneider Electric for 25 years. And when he started to write the first line of code for our product, it was written in assembly code. So today if someone new is hired, he has to read some assembly code. So it's not really great. So we would like to move on something more open source. So maybe someone new that we hire will know the technology, and the ramp up will be less significant. So then we started to look at other technology, and we found out that ThreadX, maybe you know this RTOS, it was first from Microsoft. And in ThreadX, they are implementing what they call modules. So modules is doing exactly the same as LLEXT. It means we can add a new module to a product on top of ThreadX, and this is working fine. We didn't pick this technology because in other LOB, we had some bad feedback, and a few weeks later, we saw that Microsoft was moving ThreadX to the Eclipse Foundation, so we said, okay, maybe they are dropping the project, maybe we won't go there. Then we look at other technologies, like I won't say the name, but it was based on the Java machine technology. So it means that you could write any modules on top of the Java machine. So it was really nice because everything was sandboxed. And but for us, it was a big drawback because it meant that we had to rewrite all our products, all our firmware, from C and assembly language to Java language, and we didn't want to do that, too much time consuming. So we looked at Zephyr, and we found out that it was a few months, many months ago now, so last year, this new feature was, this new subsystem LLEXT was rising, so we had a look at it, and it was very promising from what we wanted. So what does LLEXT? What it does is very simple. It's taking a L file. So I think everyone knows the L format. It's like an open source format. You can. It's like it's cut in different pieces. We have a header that says that you have different sections, and in this section you have the text section for the code, and you have the data section for the data, or the BSS and unit, etc. So what does the LLEXT? First, it parses the whole ELF. And it's looking for the different instructions about which are about the relocation. So first you have to look at you have to find the instructions. So different moves, jumps, and thumb harmony instruction. And you look at this instruction, you decode them, and then you relocate them onto RAM memory to be able to execute the code. So when we started there was only one backend. It was the serial lines. So someone who wanted to use LLEXT had to build an F file and send it on the target via the serial lines to get it parsed, to get it onto the RAM, and then execute it. It was coming with a very simple example, which was doing one print K to say hello world. But it was very nice because hello world was implemented in the base firmware, so it proved that an extension could call some code from the base firmware. The only problem at that time is that when we took the project, it was at a POC state, so it was not very stable. It was very unstable because if we tried to do 2 print Ks, it crashed. So that's how we started with LLEXT. So what we had to do is what I call enhancement. So it was kind of adding what was missing. So there is not so much missing. We added the ARM instructions that were missing. So I think it was only the thumb extension that move and jumps. We also added a mechanism to export and find symbols. What does it mean? What it means is like when you have the two firmware, so the base firmware and the extension, they all have symbols, and they need to communicate to each other. So the base firmware has to find symbols onto the extension. So that we implement some function to say, okay, look for some hard-coded symbols. So init, start, stop, exit. And the other way around, the extension has to know where are the other symbol from the base firmware. So if the extension wants to create a thread, for example, it has to know where the thread function is. So we had this mechanism. What was also nice for us that you cannot find it yet in Zephyr, but maybe soon. It was a way to build the extension health, because when you build the new health, your extension, you have to use the same, let's say the same GCC option and the peak option to say, okay, I want to build the extension with the same mechanism. So we edited the CMake files and the kconfig, etc. to make it work. And I think today, if you look at the code in Zephyr, it's not the same approach they use. I think someone pushed a way to build the extension out of the tree. So there is like a small SDK to build extension. Maybe we'll have to talk with them to say, okay, maybe we can have the two mechanisms. Anyway, we try to propose our way to build the extension from the tree. It's a bit like in Linux. In Linux, when you start kconfig, you will see like your driver, your modus, and you can tip the driver, and it will be built in. And you can say it will be a module, so it will not be built in the kernel. It will be built just next to it, and then you can load it. It's the same mechanism. We try to mimic it. And the last thing we were needed was to install some kernel callbacks because of the mechanism of Zephyr. Zephyr, if you want to be attached to an IRQ, or if you want to be attached to a GPIO, you have to use a callback. So we implemented a way for the extension to be able to install a callback inside the kernel, so we can get noticed if there is an IRQ or if there is a GPIO. I will show that a bit later on. How? We also had some modifications, so we add a new backend because we didn't want to have the target plugged to the host computer to send the health files through the serial lines all the time. We wanted to be able to put the health files onto the file system and then ask the target to automatically load it at the start. And to do that, we also add a configuration file. So it's a very simple. It was a very simple syntax. I think we took the ini syntax. Maybe you know it. It's just a few lines where you say I have one health file which is located on the file system at that path, and then the LLAC finds this file, reads it, and so okay, you have like many health files, and the loads automatically them onto the memory and then run them. We also fixed a few issues, and it was not very big deal, to be able to do many print cases, not only one. And then we also proved that we could call any function from the kernel. It was not only print case, but it could be any function that we export. So create a thread, create a mutex, create a semaphore. When you create a mutex or semaphore, you have to take care about a few things like permissions, because in Zephyr you have to add permissions to do stuff like that. So you have to keep in mind that. So to prove that everything was working, I will show you a proof of concept that we wanted to do. So on the picture, you can see a counter plugin. So yeah, because when we started to implement our own mechanism, we didn't call them extensions, we called them plugins. So I didn't re-edit the picture. So when you read plugins, it means extension. So what we did is to create two extensions. Was a very simple extension that we call counter. Basically, it was it's counting the number of frames that a master. I will do a quick summary. We plug the target was configured to be a slave on the CanOpen stack. We use our host computer to be the master on the CanOpen stack. And the CanOpen stack on the target itself is supposed to be an extension. So we took the code in Zephyr. If you look at modules, which is an external module, you can find the CanOpen node, which is open source. And we, instead of make it built inside the firmware, we built it as an extension. And we wrote a really simple other extension, which was a counter which is counting every frame that which is incrementing a counter each time a can frame is received. And we plug let's see if a picture, the small blue button, just to prove that if we press the button, we can have a callback on the GPIO and reset the counter. So with all of that, you can prove that first you have a product which don't have the CanOpen stack, so there is no communication possible with the host on the CAN bus. You then load the two extensions. So your product is now having the CAN open stack on it. So it was it's really a runtime amend. And then you can communicate with your host through the CAN bus. In order to do that, we use the STM32 Nucleo board. It's an innovation board based on ARM Cortex-M4. We installed two extensions of the file system, and with the configuration file to say, okay, we want to load them. And we also had to do some work with the MPU, because at first the MPU was not supported. Today it is supported, but there is some conversation we have to with the community to be sure that what we do with the MPU is still in the community philosophy. We don't want to, well, we will do a proposal. After that, we went a bit further, that we tried to experiment the XZIP, because from now, when you do the ELF is loaded into the RAM, but we wanted to know if it will be able to flash it on the ROM and be able to execute it on the ROM. We also look at the Zephyr user space. So here we had some kind of issue with the MPU, because there is not we don't have the same philosophy than the Zephyr community on the MPU, so we have to open a conversation about that. And we did some performance measurement to be sure that even if a code is running as an extension, or if it's running as built-in, there is no impact on the performance as real-time or stuff like that. I will show the demonstration afterwards, but here we have a quick view about what's happening at the very, I don't know if you can see. Let's say we can see it. It's just written loading plugins. So we here, Zephyr is starting, and it says I'm loading the plugin counter, and I'm loading the plugin CAN open stack, and it's running then. I will try to show you with I brought my webcam, and I will do the demonstration at the end. You can read it? Well, it says loading plugins successfully loaded, and starting plugins. So you have the first steps. Is like first you take the extension, you load it. You say, okay, it has been loaded fine, and then you start it, meaning you found the symbol in it inside the plugin, and you're able to call it. And we did that 2 times, so one for counter and one for the CAN open stack. To do a performance analysis, we use the conventional tools. So I think many of you knows MATLAB Simulink. So Schneider is using Simulink to do some simulation. So we do model-based design. So we basically built a very simple model-based design. We injected some input vector, and we recorded some output vector to build curves. We did the same on the target. So we took the code from Simulink, the C files. We can auto-generate it. And you compile this code as an extension, and you send it to the target, and then you inject the same input vector, and you record the same output vectors, and then you compare. So here is the comparison. So what is great is that you only see 2 curves, but in fact, if you look at the legend, you have 2 times 2 curves, because there is 2 blue curves and 2 pink red curves. You can see them because they are completely overlapped. It means the simulations in blue is giving the same result as the code running on top of Zephyr, meaning you can run the extension, you can run your code on the extension, and there is no impact on the real time at all, because here you have the exact same outputs giving the same input vector. So it's really great. It means you can use the extension in your product to do your new know-how. And then we use the more sophisticated tools where you need to have some license. Zephyr is already supporting Percepio. So if you look at Zephyr source tree, you look for tracealizer, which is Percepio tools and analyzer tools. And then I won't go into too many details here because it's not the purpose of the presentation. We had to check a lot of stuff like system. You can check the tags, the system calls, user events, CPU load, etc., etc., etc. And that's what we've done for some times. And we get to reassure that the extension is not changing the real time, the task scheduling, etc., etc. So what are the impacts of the products? There is some benefits and some drawback. So the first benefit is what we wanted. It means you can do some partial update. You don't need to send your whole firmware through your network or your way to update the firmware. You can only send the extension. So you spare some space and sometimes on the networking. Maybe it's not free to use the network to update your products. And you get some impact on about your verification. You get a lot of time because you can only verify the extension in your product, and so your time to market will be a lot smaller. The biggest issue that we can see with the LLEXT, I think a lot of you already thought about that, is the cybersecurity. What happens if someone is able to put an extension on your product? It means maybe he can take control of your product because you are executing some code that you don't know. So here we are, I'm not bringing any answer at all. I'm bringing some question to the Zephyr community. And I'll just say, how do we do it with being cyber secure without exposing our new product to threats? And is there a way, for example, when you use your bootloader, the first stage bootloader, second stage loader, then your secure application, maybe we'll have to be able to build some secure extension, something like that. Or is it enough to simply make sure that the extension is coming from a source that you know, and maybe with cybersecurity tools like some private key, secure key, etc., etc. So it's a question. We are bringing question here. Maybe I hope we will have some questions, some answers. And the other question is about safety. If we actually build some extension of your product, do you have to, first of all, can you certify as a safety level a product which is using extension? Is it possible or is it not possible at all? And if it is possible, now if you update your product with an extension, do you have to do the certification again or not? Because maybe you are updating some part of your product that is not certified. Do you have to redo everything? Do you have to redo everything or not? So that's some question we'd like to have, some answer we have to have. Okay. Here is the last part of my story, is what happens when you are in an industrial company and you want to share back your code, because the point is, so we use Zephyr, we took the LXT technology feature subsystem, and I wanted to be able to share it back because we improved it and we wanted to share it back, and I wanted to see if it's possible as an industrial. Because when you do that with open source, since you share with the world, it means you're also sharing with your competitors. So first you have to be sure that you won't get any impact on your products, on your sales, and you have to be sure that your whole company agrees of it. So first, what you have to do is what I have to do. It was to check that we had a process internally. Which is not the case at all. I don't know if in a different company you have already some processes to share some code about open source, but in the Schneider it was not the case. But now today, a process has been built, and it's not fully operational yet, but we are I'm really proud of that. So like we actually can share some code now. I will share something at the end about that. What we had to do was looking that we are not using any patterns, some internal patterns first. So as a big company, like you have to make sure you go to see your IP department if you have one. It's not always the case, but we do have some lawyers, so we have to check with them first if the code is not using some other pattern, maybe, or competitors' patterns, and that we have the right to share it with the community. And the last one, but not the least, you have to get an approval, which is very complex things to do with a company. You have to get all the people you need. Okay. And had to also to check the process from internally with externally, because Zephyr project has a process which gives you the guidelines. If you go to the website, you will see some documents which say you have to do this, and like that. It's not really to make them both work together, because when you look at Zephyr, since it's a Git process, they are used to have some small commits to review, so it can go fast. But as a company, you will never propose small commits. You will have to do the whole stuff. So in my POC, I was giving the whole feature, and then when I wanted to push back to the community the whole feature, the first answer that I got was, "You're crazy. There's too much code to review. Can you please cut it in small pieces, because we have to understand what you do, and we have to be sure that it's secure and you don't do anything crazy." So that's what I had to do. And pros and cons, which is great with the Zephyr community, that we have a fast time reaction. There are many people, I was really surprised with that. I got answered like half a day. I got an answer and review about my code, and it was really ongoing. I was really impressed. And because there is a lot of eyes, so here it's a pros and a cons. Because since there is a lot of eyes, they review the code, they found some issues with my code, which I had to fix. But also, the drawback is that since you have a lot of eyes, means you have to content everyone. You have to make sure that everyone is happy, because if someone is not happy, he will say no, you have to do the review and start again. Well, that's life in Git, but that's the way it is. So, but it's a great thing. So I just want to show you that something I'm proud of is, like a few days ago, I got my first pull request accept on the Zephyr community. So it proves that it is possible as an industrial to share back some code. So here there is not everything; it's already just a small piece of what I want to share about the feature. But it's already a success, and it means it's possible to share back. That's it. And I would like to, if I have time, yeah, I have a lot of time. I will show the demonstration. So it will be very, very quick. So what you can see on the picture, and I will show you the rest of the demonstration. You have the ST board I was talking about. You can see the green board is a piece of our product. I didn't want to use the whole product, so I cut a piece of it to get the connectors. You can see the CAN module, which is basically transforming the signals to get the CAN of the campus, because the board is not doing it. And then on the CAN option board, I plugged an adapter, which is doing some CAN to USB, and the USB is plugged back to the host computer, and then you can have communication on the CAN bus from the host to the target. Let me try to show you. Okay, you have it for here. This one is just next to me. So, okay. Top left-hand side is communication, which will be the CAN communication from host to the target. Bottom left, it's console and the target. And on the right-hand side is my Zephyr project, where I built Zephyr and the extension. I will just use it to show you that if I do just ls on /f, well, you can see it because maybe it's too small. But basically, just to show you that on the file system now, there is no extension at all, and there is no configuration file. So if I start my board, reset. I need to open it first. Sorry. Cybersecurity. Up. So here is the serial line. If I start it, Okay, so here you can see that there is no CAN. The CAN interface is ready because the CAN physically is there. There is no CAN stack, and you can see that there is no configuration file. The plugin.txt is not found, so nothing is happening. And if I try, okay. If I try to start the Python, which is implementing the master on the CAN bus, it won't work. We have some errors because there is no CAN on the target, so there is no communication possible. So now, on the right, I'm copying the extension file plus the configuration file on the target. So now if I restart it, it will be fast, but as I showed you a few minutes ago, you can see that now the two plugins are loaded and the CAN stack is started. So you can see starting plugging CAN open node. And you can see that it's printing that there is just to show that there is a loop on the CAN which is waiting. And starting the pattern now. So you can see that you can see a counter which is increasing, which means there is some frames that are exchanged between the target and the host, and it's incremented. And if I press the GPIO, like I showed you a few minutes ago, the counter, which is now 47, 48, we go back to 0. So 5001, it means the extension, which was a CAN open stack with a small client, was able to communicate with the host and reset the counter according to the GPIO. So you can see that, hard to explain, there is a communication with everything. So that's pretty much it. That's it. That's it for today. Thank you. So if you have any questions.
Thanks. Hey, how's it going? That was a great demo. Just curious if you guys were able to debug your LLX as well, and if you could maybe just talk about that process.
You can debug it as any application, except that when you are using GCC on GDB, you have to load the symbols of your extension because the address are completely wrong. Because when you load the elf, the address are wrong, and they are partially updated with the LXT when they are loaded. So if you add the address to GCC with GDB, really simple, you can debug it as any application. It's not possible with IAR.
Okay, thanks for your presentation and for the contributions. I have a question on how are you going to handle in the company the long merging process? Like if now it takes a long time to complete the merge, how are you planning on supporting this internally? Like, are some products being developed now? Are you going to use your own version internally and then update? Is this something that...
That's a secret. I cannot say today that we are using Zephyr. So no, we are not using Zephyr, but yes, I will do the maintenance of the code to make sure that the community have the whole feature, if possible. And maybe sometimes we will use Zephyr, but I cannot say that today. It's not something I can say.
Have you done any measurements on like the overhead of having to store this ELF file as opposed to just having it in your application to start with in terms of ROM space or RAM space?
Yeah, we've done lots of. I didn't put it there because it depends on the target. But yeah, we do some measurement about the ROM. So on the file system, you have the space you have to use. Then it is the same on the flash. And also, what was really important, it was the time to actually load the application, which is, I think, the very, let's say, the bad key here, because it takes a lot of time to parse, because you have to take the whole text section, and you have to parse it entirely to put it on the RAM, because you have to find the instruction to be able to edit them. And this is taking for the small extension counter, and my board, it took 10 milliseconds to load it. So it's for a very long time, lots of time. And I think it was, I don't, if I check here, that we don't, here you cannot see it, but here it took 160 milliseconds to load the can open node stack and on the Cortex M4. So it's a lot of time. I think it was your question? More or less. Sorry.
You have a question? Oh, okay. Go ahead.
So, is it possible to modify the existing running kernel functionality, let's say a single API, or else it's only for the user space complete applications starting from the main?
Not sure what you mean. You mean about the user space? Can you?
Okay, so we have seen that the piece of code, it's a print K. Instead of that, maybe a kernel scheduler function, whether we can be able to modify that on the runtime using this piece of code, or?
The philosophy of Zephyr on user space is not doing like this. Like in user space, you have to here you can create a thread. So you can create a thread as a user of the kernel thread. There is no limitation. It means the extension can create a kernel thread. So it could take control of your board, and if you want to create some objects, you have to give the permission here. So the extension cannot give itself the permission, so it's not working well now. About the user space. We have one question here.
I just had a question.
Sorry.
Just wondering about the security implications for this. Like, does it open up the possibility for injecting some bad code runtime? And what could be done to protect the applications? Or
I think, as I said, like if it depends. First, you have to make sure, since you are using the file system, first you make sure that no one can read your file system, because if you can read the file system or write into it, you can do anything you want. And then you have to make sure that your code is coming from a secure source, so you can use like a GPGK to say, okay, it's a package from Schneider, and then you use your private key and public key to say, okay, it's Cypher, so it's not possible to modify it. But then after, I don't know if when you load the application, if you have to add some security, maybe just MD5 sum is enough, or maybe you have to cipher it as well. I don't know. So I would like to talk with the community about that to get their idea.
Questions for Cedric? All right. Thank you.
Thank you.